Okay, here we are, chapter 7.4 notes, the other trigonometric functions. We are taking a look at pages 12 and 13. So, exercise 15, entering these on the calculator. We can't enter them the way they're written, but we can find the theta where the sine is 2. So theta is inverse sine of 2. If you plug this in, you get an error. If we take a quick look at our unit circle here, remember that the sine is the y function. The very largest sine we ever have is 1. The very smallest is -1. So sine does not live outside those bounds at all. So the domain of sine, we'll just do that here. Domain of sine is -1 to 1. Same thing with cosine. When we try to solve for this theta and we plug in inverse cosine of -1.1, our very largest cosine is 1. Our very smallest cosine is -1. So the same thing happens here. The domain of cosine is -1 to 1. Okay. So that's pretty much it for this page. We've got this nice big box at the bottom here. We have got our reciprocal identities. We've talked about those. Moving down the left-hand side, we've got our cofunction identities. Spent a lot of time with those, finding the complement. So the function value at an angle equals the cofunction of its complement. Quotient identities, we've kind of talked on briefly. Me. We'll talk about those more, even and odd functions, and then the Pythagorean identities, which are going to be super useful as we move forward in these trig functions. Page 13. So I'm just going to fill in the other sides on our triangle here. I got x, I got y. We want to remember that the tangent of what's this angle called t is our opposite side over our adjacent, our y over x. We need to also remember we can write y as sine of t and x as cosine of t, which makes the tangent of t equal sine over cosine. Similarly, our cotangent, x over y, means cotangent t can be written as cosine of t over the sine of t. These are our quotient identities. These are the trig functions that can be written as a quotient of two other functions. Pythagorean identity, the best. So much we can do with this. We've got side x, side y. Again, we want to remember that x is the cosine of t and y is the sine of t. Pythagorean theorem, reminder here, says that x squared plus y squared equals 1 squared. Remember, we're in the unit circle. Our x is cosine. Our y is sine of t. Cosine squared t plus sine squared t equals 1. This is a big deal. This is our Pythagorean identity. Super big deal. This becomes incredibly helpful. We will use this a lot. Okay. How to derive the other two. We've got two other Pythagorean identities. So let's start with what we've got. And I'm just going to flip these around so it matches. Sine squared t plus cosine squared t equals 1. I'm going to go ahead and divide everything by sine squared t. I mean, I could divide by whatever I want to, right? I do this because sine squared over sine squared is 1. Cosine over sine is cotangent. 1 over sine is cosecant. That is another version of the Pythagorean identity. Keep in mind we can move things around. So cotangent squared t also equals cosecant squared t minus 1. I don't know where the theta came from all of a sudden. Let's see, what else could we do? We could say 1 equals cosecant squared t minus cotangent squared t. Different versions of the same thing. Last one here. We're going to start again with the Pythagorean identity. Again, you guys, this is the only one that I remember. I know that if I see a cotangent squared or a secant squared, I can divide by whatever I need to make that other trig function. So here we're going to divide by cosine squared. Sine squared divided by cosine squared gives us a tangent squared plus 1 equals secant squared t. That is our other, gosh darn it. That is our other Pythagorean identity. Again, we can move things around. 1 equals secant squared t minus tangent squared t. We can have tangent squared t equals secant squared t minus 1. Different versions of the same thing.